Hello and welcome to today's episode of One Man and His Whiteboard. Today we continue in our discussion on an introduction to IP subnets. So now that we've talked about the network segment and what a waste it is, it would be wonderful if there was some kind of way where we could do some trickery like this. If only we could make it so our network segment could be split, maybe like this. Let's agree so everybody on the green network segment is 10.1 something, and everybody on the purple segment is 10.2 something. Well, it's a lovely idea, but everybody on the network segment has to have the same number. So how can we put 10 on the right and 10 on the left? Well, there's a little code sequence we can put in to let the router know that we're doing some trickery. If we were to put in the network address on the network as 10.1 something, and then we use a mask of 255.0.0, and then do the same thing on the right hand side on the purple network, the router would be, hey, because obviously it's a Californian router, hey dude, what you doing? You're using the wrong mask. A class A mask is supposed to have a 255. And of course we could signal this by doing, oops, give me a second, my mouse seemed to have gone a bit mad there. We could signify this as well by doing the /16. So we draw it as /16. Please understand, when we type in the router address, we type in 10.1.0.1/16, or we type in 10.1.0.1, then put the mask in of 255.255.0.0. And this signals something special to the router. The router will be, whoa, dude, what are you doing? You're using the wrong mask. And the router will then go, oh, I see what you're doing. I see what you're doing. You're using 16 bits of networking, 2 bytes of networking on a class A address. So we are signaling to the router we're doing something clever. It's a class A address, so the first field is network. It's a class A address, so the last 2 bytes, the last 2 fields are host. But by using ones in the mask in a host field, it's a secret code word we have with the router to say that we are stealing bits from the host field and we are using them in a special way. Now, you can't call them network because 10.1 is going to confuse a lot of things because 10 is the network. So we use the word subnet, and I'll draw this with a lowercase n to signify that it's a stolen network field. So now I can more efficiently use my IP address space, but you still have to follow the golden rule. Everybody on the network segment has to still have the same network address. Now in this case, we are defining that the first 2 bytes are a network portion. The first part is the network portion. The second part is a subnet. So now you understand what a subnet is. And I appear to have a mouse problem. I don't want to write in that rather weird way. That's better. I think my mouse was a little bit too far away from my computer. Maybe it's time for a battery change or something. So now we have a subnet. Much more efficient. And of course, by putting a 255.255.255.0 mask in, we could create 2 fields of subnetting. Now that would work really well. Say for example, we had a university or a college campus and we had buildings. Well, we could make this building, hey, everything in this building is going to be 10.1. And everything in this building over here, as you can see, my 3D drawing skills are legendary. 10.2. Yeah? 10.1, 10.2. Fantastic. Now we could make everybody on floor 1 use 10.1.1/24. We could use everybody on floor 2. They can be 10.1.2/24. And of course over here, people on floor 3 following the same pattern would be 10.2, because the first 2 bytes signify the building, the third byte signifies the floor. As long as you haven't got more than 256 minus 2 hosts, you will be fine. Now remember, it's 256 minus 2 because 0 signifies the network itself, and all ones, 255, signifies a broadcast address. Remember, you need to steal one more address as well for the default gateway. So you can only actually have 254 hosts, one of which is the router address itself. So you can only have 253 devices plus the router. And that will be shown as a 24. And just to explain a little bit more what I said, how do we refer to the network 10.1.2? So the network 10.1.2 will be written down as 10.1.2. Now its full name is 10.1.2.0 because it's got a 0 in the host field. Because remember now, in the scheme we use in, which is /24, these are the network field, this is the host field. So when the host field is all 0, it represents the network. And the broadcast then, of course, would be 10.1.2.255. So converting all the host bits to a 1 represents the broadcast. So if I wanted to talk to every host on the network 10.1.2.0, I would address it to IP address 10.1.2.255. So now we understand the basic premise of subnetting, to steal bits from the host field and allow them to represent a sub-network concept. And we can steal as many bits as we want, obviously to the limit of the number of hosts field. Because of the rule of the 0 and the 1s, you can't actually steal all the bits in the host field because you'd have no space left for hosts. So in the example here where we have 32 bits in our IP address, people think, oh, you can steal, so we could steal 8 plus 8 plus 8 is 24 bits. No, you can't do that because now there's no bits left for host. Okay, so we can't do 24. So we can do 23 then? Well, if you think about it, if you do 23, that only leaves 2 bits for host. And those bits can be a 0 or a 1. Well, in networking, in computer mathematics, if you only have 1 bit and it's a 0, then all the bits are 0. If you only have 1 bit and it's a 1, then all the bits are 1. So it breaks our 0 and 1 rule. So quite often you'll find the maximum number of bits you can use is up to the limit of the hosts minus 2. So if there are 24 host bits in a class A address, the maximum we can steal for subnetting is 22 because we always have to leave 2 bits for host because 0, 0 is not allowed and 1, 1 is not allowed. So 0, 1 and 1, 0 will be the 2 host numbers that are allowed on that subnet. So later on you'll hear me talking about a point-to-point network that requires 2 IP addresses. The key thing to understand is you've got to allow 2 bits of the host field because of the all zeros and all one rule. So in a class B address, where we have 16 bits for networking and 16 bits for host, the maximum number of subnetting bits we can take is 14. So remember, whenever you calculate how many hosts there can be in a network, you've got to take 2 of. Whenever you want to calculate how many bits we can use as a subnet, you've got to leave 2 bits for the host field. Okay, that's us done on our talk on subnetting. We'll see you next time.